hoping for. I want to see you be successful on this test. We don't need anybody to have to retake the test. So if you will turn to chapter 11 in the book, page 784, the end of the book, or the end of the chapter test. And it says, in exercises 1 through 6, find the area of the shaded polygon. This is a parallelogram. Number 1 is a parallelogram. And the area of a parallelogram is just base times height. It's important to remember this cannot be slanted height like we see over here. Okay, we don't measure height leaning against a wall. It's got to be this standing up height. And we kind of remember the way we picture it is that if you were to cut this triangle off and stick it over here, it would be a rectangle, and the base of that rectangle, or one side, would be the 7 centimeters, and then the height would be 4.7. So we say area equals 7 times 4.7, and this is not clearly times there. 7 times 4.7 is equal to 32.9, and that's centimeters squared. And we double check to make sure that it doesn't give us any instructions about rounding. It does not, and to the tenth place is a very reasonable place to round it. Alright, looking at number 2, we have a triangle. The area of a triangle is equal to 1/2 base times height. You may have these on your theorem list, but you should memorize them because they will probably not be given to you on an SAT. And now in this case we can think of the base as being, well, this is a good base, I'm sorry. Okay, the base and the height are found wherever the right angle is. If you don't have a triangle with a right angle, your height will be wherever there is a right angle to another line, which will become your base. Okay, and if this one were, rather than being oriented like that, looked more like, oh, let's see, perhaps if the person who was working this problem had written it such that this was the base, then the height, well, that's really kind of a right angle there. Let's see. If we draw this a little bit differently, then we can see what would happen. Because sometimes it looks like okay, you may have your right angle, like if this were the base, it may come down here. And then the real triangle is actually right here, but the base is, whoops, the base becomes this part, and the height becomes this part, even though they're outside of the triangle. And that's okay, because we have a right angle right here. And then the base is not actually that entire thing, it's really just this part that is there at the triangle, and then the height. Okay, just to clarify that. Let's make all that disappear. Okay, so our base times our height, we don't know what our base is, so we're going to have to use the Pythagorean theorem to find it. We remember that across from the right angle is the hypotenuse. So it's a squared plus b squared equals c squared, where c squared is the hypotenuse. So we'll start with 13 squared, and then we'll say it doesn't matter whether you think of 5 squared as being a squared or b squared. It doesn't matter. Okay, so this is going to actually be when we subtract 5 squared from each side. So we'll punch into the calculator 13 squared minus 5 squared is equal to 144. And that's b squared, so then we have to take the square root, which if you might know already what that is, but it's 12. So b is equal to 12. So that's going to be our base. Okay, and then our height is where the right angle goes up. That's going to be our height. So 1/2, 12, times the height, which is 5. And I just like to cancel. You may just want to punch that into your calculator that way. So it's 30 feet squared because it is area. Okay. this can be seen one of two ways. It can either be your, let's see, it can either be a parallelogram with a triangle. Wow. Okay, so we have to look at what we have here. We can see this 9 is sticking way over here like this, and it seems comparatively just a little bit shorter than this one. And even though they don't always draw them to scale, when you have numbers, you try and figure out what they go with. More than likely that 9 goes with that triangle over there. And when it's a parallelogram, opposite sides are congruent. So this has got to be 18 centimeters here. And you can work this one of two ways. You can figure out the rectangle, or the parallelogram, I'm sorry, and then figure how much the triangle is and add those together. Or you could work this as a trapezoid. We'll do it both ways. Okay, if you want to see this, it looks like they want you to do the area addition postulate, which tells you that you can add up the areas of a figure and you'll get the total area. So we're going to start with that. We're going to say the area of a parallelogram is base times height. So that is 18 times 10, or 180. And then we're going to look at this triangle over here. That's really fat highlighting. Okay, and we see that on that triangle, the base is, you can't really see that. The base is right here, and that's the 9 centimeters. And then we see the height is right here, the 10 centimeters. So we do the area of a triangle. It's always helpful for you to label everything you do. It makes it much easier to find what you're looking for. Is equal to 1/2 base times height. Also, if you start by writing the formula each time, you'll memorize it over time. That'll save you time. 1/2 base times height. Okay, so half of 10 is 5, and 5 times 9 is 45. So that's the area of your triangle. Now remember, I told you when you add the two areas together, you get the total area. So we're going to add 180 and 45. And it's always wise to use a calculator just because. So the total area equals 225 what? Centimeters squared. And this is centimeters squared. And this is centimeters squared. And you could actually even put your centimeters into the actual problem. Centimeters and centimeters. Then when you multiply, you get centimeters times centimeters, which is centimeters squared.